Hi everyone. Today we will be discussing the chapter of limits and continuity. This is the first video for the chapter of limits and continuity. In this video we will just go through very basic definitions of limits and continuity, and then we will do a very simple example. In further videos we will go into more details of this topic. So let us start by defining limits. So first I would like to go through a convention in limits, basically trying to explain what a notation means, because notations will be used heavily. So in limits, if you see something like this, limit x tends to a, this symbol x arrow a means x approaches a, and then we write fx. This is the notation, and basically this notation is trying to say that whenever a value of x, a variable x approaches a value a, let us say a is equal to 2, then let us say x approaches the value of 2, then what is the value of the function fx? Any function, x square, x cube type function, sin x, cos x, any function fx, and what will be the value of the function fx when x approaches a? That is the convention. However, what is important here is to realize and understand that what does this mean? What does limit x tends to a really mean? So the first and golden rule for limits, and that is something that I will really emphasize, and I hope that you will never forget this rule, because this is the super most important thing for you to know about limits, is that x approaches a is not equal to x equal to a. I think this is something that almost is like I'll write here golden rule, because if you forget this, if you start equating x approaches a as x equal to a, then you will go wrong in all the questions you will try to attempt for JEE. The reason that I am emphasizing this again and again is because we will see some more specific problems in later videos, where whenever you are not clear about this rule, you will get the wrong answer. Okay. So remember, x approaches a does not mean x equal to a. What do we mean by x approaches a? Let us look into that. So let us say we have a number line of x. There is a number line, okay, and this is number line for x, variable x, and you have a value a. So x equal to a at this point. So if x is approaching a, then that means we can approach to this constant value from either this side or this side. Okay, and when we approach it from left hand side, where basically the value of x equal to a would be less than value of x would be less than a, that is known as the left hand limit. And when you approach it from the right hand side, that is known as the right hand limit. So just let me emphasize a little more about what do we mean by left hand limit and right hand limit by giving an example. So let us say x approaches 2. Okay, I am saying that x approaches 2. Now what would happen if I am having the left hand limit of x approaches 2 is that conventionally we will write LHL, left hand limit. This is LHL, and right hand limit is RHL. So LHL means we can, in convention we will write x approaches to negative, because this is less than 2 but not equal to 2 and very very close to 2. So when we mean limit, we are approaching that value but we are not equal to that value, and in the left hand limit case we are less than that value. So what does that mean? X would be equal to 1.99999 and so on, but it will never be able to reach 2 and hence would not be equal to 2. Okay, in the left hand limit case, but it will not be equal to 2 again. So if x approaches 0 negative, then it will be very just slightly less than 0 but not equal to 0, and a technical term to define that is it is infinitesimally smaller than 2. Okay, very small but not the same. So again, x approaches a does not mean x equal to a. Okay, and in the right hand limit, when we say that when we are evaluating right hand limit, then we say that x is approaching to positive because it is a little larger than x equal to a, and in that case x should be 2.00000 and so on, but not equal to 2. So I hope this makes sense, that what do I mean by that when x approaches to positive. Okay, and let me try to give you an example so that you probably would be able to understand this more. So let us take an example. So the question says evaluate limit x tends to 2 x square plus 2. Okay, so we have to evaluate limit x tends to 2 when the function f(x) is x square plus 2. So there are two possible scenarios, left hand limit and right hand limit. We can approach 2 from the left hand side or the right hand side. So let us first evaluate left hand limit. So how will we evaluate this function? So one of the ways to do it is direct substitution, and we will talk about these ways more in the later part of the videos. But one of the ways is that you can just directly substitute this value 2 here and then evaluate the function. Again, when I substitute 2, I am not substituting exactly 2, I am substituting something which is very, very close to 2. So the answer which will come will also be very, very close to some value, not exactly the same value. So that is implicitly assumed when I am defining any limit, that the value is not exactly the same value, but a little less than the value or larger than the value. Okay, so let us substitute 2 in this x square plus 2. So 2 negative square plus 2, and 2 negative is just slightly less than 2, but the square would be slightly less than 4. So when we add, this would be 6, and approaching 6, not exactly 6. But we don't put a sign of arrow here because that is implicitly assumed when we write left hand limit or right hand limit. I mean, this is just convention. It might be a little difficult to become very comfortable with this convention. It will take some time, but you will realize with practice that this is how it is. And now also let us define right hand limit, and let us see, that will be 2 plus square plus 2, and that is also 6, right? So that is how we define left hand limit and right hand limit, and this is a very easy example, just trying to show you that a function will be approaching 6, will not exactly be 6. If I want to look at this graphically, let us try to sketch x square plus 2. So you can probably very easily guess that x square plus 2 is something like this, or a parabola opening upwards with a value of 2 at x equal to 0 and a value of 6 at x equal to 2, right? We sketch the graph. So the left hand limit means that we are approaching the value of 6 from the left hand side, and we are approaching the value of 6 from the right hand side, right? So it is not exactly 6, we are just very little less than 2 and little more than 2, but the value is approaching 6. Okay, so this is just an example. Graphical ways would be dealt in more detail in the next part of the video. Now some definitions here. Let us also evaluate the function value of 2. So these left hand limit is approaching a value of 6 from both sides, left hand limit and right hand limit, and what is the value of function at x equal to 2? So let us evaluate f2, and f2 is also exactly 2 square plus 2, and that is 6. Okay, so there is some definition that I want to go before, so that we can define few things. So a limit exists So whenever left hand limit is equal to right hand limit, that is when the limit exists, and a function is continuous when left hand limit is equal to right hand limit is equal to f of a, continuous at x equal to a. Okay. So this is the definition for limit, and this is the definition for continuity. Now, so a function is continuous at x equal to a when LHL is equal to RHL equal to f of a, which is true for x square plus 2, where at x equal to 2, left hand limit is equal to right hand limit is equal to the function value. And what does it physically mean in a terms of an understanding is that the two values are approaching the value of the function from the left hand side and the right hand side, and hence the graph is continuous. There is no discontinuity or there is no break in the graph. Okay. So I hope you are able to now understand what do we mean by limits. So in limits, we mean that we are approaching a value, the x approaches some value, but it is not exactly equal to that value, it is slightly smaller or slightly more than that value. When it is slightly smaller, we evaluate and call it the left hand limit. When it is slightly larger, we call it the right hand limit, and then we can also define the exact value of the function at that point, and that is the function value. So the definition of limit existing is when left hand limit is equal to right hand limit, and the function is continuous when left hand limit is equal to right hand limit is equal to the function value. So we will talk about graphical interpretation and continuity in more detail in the next video. I hope you enjoyed the video and look forward to seeing in the next video. Thank you.